All right, in this video, we're going to start talking about word problems. Now, word problems in general are usually challenging for students, but they really are where the math kind of meets like real world scenarios, right? So it's kind of the point where these equations that we come up with, they actually mean something, okay? Now, there's kind of two different types of word problems we're going to start off with. The first one I already wrote down, which I wrote these questions down ahead of time. So if you guys need to pause the video and write the question down and then press play when you want to get started with it. But the first kind of question is the kind of question where they give you like an equation in the actual paragraph. Okay. So the first step to solving any word problem, regardless of whatever it is you have to read it. Okay. I know that sounds kind of strange, but I can't tell you how many times where a student will ask me for help with a word problem, but they haven't actually read it yet. Okay. So the first step to any word problem is to make sure you read it. Make sure you understand what are they asking for. Okay. So the first one on the screen right now says the formula for the area of a triangle is A is equal to BH over 2. Okay. Uh, what is the area if the base is 2 feet and the height is 5 feet? Okay. So this is the kind of question where like they give you all the information you need to know, and essentially you just have to know where to plug in the correct numbers. Okay. So it's just a context question. So they gave us this formula, right? So I'm going to highlight that. Which for this, if you have highlighters or colored pencils, they might be very handy when we're going through these. Okay, so they gave us this equation in the middle of the paragraph, right? A is equal to BH over 2. Now, when you're in a geometry course, you would probably be expected to have these memorized. But for in terms of algebra, a lot of times they'll give you the equation. So they gave us the equation there, and then they're telling us what each piece represents. So essentially, we just have to plug in the numbers in the correct spot. Okay. So let's start off with the equation again. So A, oops, let me put a pen. A is equal to BH over 2. And then we have to look at the information they gave us. Okay, so they told us that the base is 2 feet. Okay, or base is represented by B. So we can go ahead and replace that B with a 2. Because we know it's 2 feet. Okay, and then they also told us what the height was. They said that the height was 5 feet. So again, we're just taking the information that they told us and we're putting it into our equation. So the height is 5 feet. I should probably do that in blue. Okay. Now the reason why I'm using parentheses is just for organization's sake. Sometimes it makes a difference, and this question is not too important. And then we just have to simplify this question, and then we're done. Okay. So now 2 times 5 gives you 10. And then 10 divided by 2 gives you 5. Okay, now the trouble is, if you were to just submit 5 as an answer to this question, that would be incorrect. Okay, the thing with word problems is that they provide you context, meaning there's a meaning behind the numbers. So when you answer 5, 5 what? Like, what's the actual question here, right? So the actual question, we have to look back, uh, the actual question is, what is the area? So that's the question we actually have to answer. If you just say 5, that doesn't answer this question. Okay, 5 what? And if you notice in the measurements in these, it's in feet. Okay, so a typical rule of thumb here is that if they ask you in words, like a word problem, you should answer with words, like answer with a sentence. Okay, so you could say something like the area is 5, and we're talking about feet specifically, so 5 feet. And this is a geometry thing. We'll get there later. But it's 5 feet, and we're talking about area, so technically it's 5 feet squared. So that would be a complete answer because you're answering the question that they asked, right, in a sentence format. So these style of questions aren't too bad because they give you all the information in the paragraph. You just have to read it and put it in the correct spot. Okay. The ones that are a little bit more challenging are the ones where they kind of give you all the information, but they don't tell you exactly what the equation looks like. Okay, so that's like the next example. Let me go ahead and scroll down. And again, I already wrote it down, so if you need to pause the video so you can write it down first, go ahead and do so. Okay. All right, step one to solving the word problem is, again, you got to read it, understand what's actually going on. Okay, so it says James is going to an amusement park with his friends. Okay, he has $50 that he's allowed to spend. If it costs $5 for admission and $2.50 per ride, how many rides can he go on? Okay, so notice they didn't give you an equation in this one. So we actually have to build our own equation. Now, the nice thing with these kind of questions is that there is kind of a general structure to these equations. Okay, so for example, we know that we're kind of building up to like a total amount, right? So we can put our equal sign. We know it's going to be equal to a total. We're talking in general sense right now. Okay, and then we also know that sometimes the other pieces, there's going to be one part that's changing and one part that's not changing. Okay, so for example, in this question where it says in here, if it costs $5 for admission, that means it costs $5 just to get in the door. That doesn't change at all, right? So that's the unchanging part. Okay, so in our general equation right here, I'll go ahead and write starting amount, or we could say it's the unchanging amount. Okay, and then there's going to be another part that is changing, like it depends on something else. So in this question, they say it costs $2.50 per ride, right? So that changes depending on how many rides James goes on, right? So that's the changing amount. Okay, so that would be the other piece to our equation. So go ahead and write that in there, changing amount. And then those two pieces are connected in one way or another, right? So depending on what the question says, you could be adding these together or you could be subtracting these together. Okay, remember, this is just a general case. Okay. Now looking at this question specifically, let's go ahead and build it. Okay. So I would recommend always starting off with the total amount. So let's go and put our equal sign in there. So in this question, the amount he has total, he has $50 he's allowed to spend. Okay, I'm gonna grab a highlighter. Okay, and that's this piece right here. He has $50. Okay, that's what he has. That's what he's allowed to go with. He can't go beyond that. Okay, and for the sake of this question, we're assuming he's spending all of it. Right? We'll get into later about inequalities and what happens if he wants to spend less than that. Okay, so he has $50. That's the total amount that he has. So when we write our equation, we know it's going to be equal to 50. Can't go over that, and for this question, we can't go less than that. We have to go 50. Okay, and then kind of already color coded these. The $5 for admission, remember that's the part that's not changing. Okay, regardless of who comes in, it's $5 just to get in the door. Okay, so that's a flat cost, a flat fee. So we know it's 5. Okay, the part that changes is the amount of rides he goes on. It's $2.50 per ride. So that phrase right here, I'm gonna highlight it in purple. This word per, that's a good kind of signifier saying that this is the part that's changing, right? So it's $2.50 per ride. So this is how you'd represent that. It's 250, so 2.50 per ride. Okay, so let's just use the letter R. So it's 250 per ride, so 250 R. That's our variable. All right, that's the part we don't know about. Okay, and then we need to connect these with either a plus sign or a minus sign. And we're spending this amount of money, right? So if we're starting by spending $5 and we're spending an additional 250 each ride, that would be adding. We're adding these together. So in this example, it'd be a plus. Okay. Now we're back to a situation we've been working with past few weeks, right? It's a basic equation. It's not too bad. We can solve this pretty easily. Okay, let me go and scroll down a little bit. So if this was our equation, right, there's our line. We could start by getting rid of that 5. Okay, so let's subtract it to the other side. Okay, 5's cancel out. And we're left with 250R, so we can kind of simplify that to 2.5R. R. And then 50 minus 5 gives you 45. And now we can get rid of that 250, that 2.5. Okay, it's attached to the R, so let's divide it to the other side. Okay, the 250s are canceling each other out, and we're left with R. And if you need to, use a calculator here. It's not a big deal. But if you plug into a calculator, you should get R is equal to 18. Okay. Now, previously in previous like quizzes and tests, like getting this far would be acceptable. Your answer would be 18. But technically, we have not answered the question yet. Okay. Let me go back up to our word problem. I'm going to underline it in red. Actually, let's highlight it. The question is, how many rides can James go on? We technically haven't answered that yet. Okay. We have an equation, but we haven't answered it yet. So you do need to answer the question with a brief sentence. Okay. So we can write a really easy, simple sentence. James can go on 18 rides. Now we've answered the question completely, and we're good to move on. Okay, we'll be working on these all week. So again, the idea is finding the significant pieces. So with the total amount, the part that's changing, and like a starting amount or a part that's not going to change.